DH table assignment. All right, so let's focus, and if you have any questions, just raise your hand so that somebody is there to help you out. I don't want any constant murmuring because, as you know, we are recording a video, and if somebody needs to reference it, it will be helpful, provided there is no background noise. Okay, so if I see people just chit-chatting or just making noise, I'll personally make sure that you get credit for it in your grading. Okay, so let's focus on this for the next few minutes, and then obviously you can go back to doing whatever. Okay, so all of you have the robotics toolbox, and we'll try to set up a manipulator configuration based on the DH table. So to do this, what we do is, as you know, we have a DH table which is link by link. So we have A, alpha, D, and theta. So we define every link like this, L1, L2, L3, because as we discussed in the first lecture, a serial manipulator is nothing but a collection of mechanical links, right? It's an open-ended kinematic chain, which is basically a end-to-end connection of links, right? You have joints and links, that's all it is. In this case, all of them are flexible, they are not rigid, because it allows for motion. If they are rigid, then there is no motion, okay? There is no relative motion between the links. So what we do is, we'll define link by link, like this, right? And we will specify this in terms of a link parameter, link structure in MATLAB, and then we'll combine the links to form a manipulator. Okay, so we'll combine L1, L2, L3 to form a manipulator. Now, MATLAB has a command called link. Okay, to define a link, you will use this MATLAB command called link. So if you just go and say help link, you get a functional prototype of it. Okay, there are different ways to define a link. For example, here. Let me just scroll this properly. Okay. So we can use the link command. One of the ways is just to use the link command, which is L1, and we say link, and I'll talk about the parameters in a moment, right? We can do this. Or we have two other commands, which is revolute, like this, or we can write this as prismatic. So in this case, you define a revolute link like this, prismatic link like this, but if you want to use a single command and define both, you can use this. I prefer using link instead of doing these two, because this is much simpler. You can define both revolute and prismatic using this format. This is only for revolute links, this is only for prismatic links. So what we'll do is, we'll try to use a link command to set up a DH table for this. So the link command goes like this, right? So the link prototype will be link theta d a alpha sigma. Okay, theta d a alpha sigma. All right. So we know that the DH table is like this. A alpha d theta. Right. So what we do is we follow this format to define a link. So L will be equal to theta d A alpha sigma. Now, these four parameters are specified here. You have these specified in this region here. You can get all four of these from the table, right? You can get this from the table. What about sigma? Sigma basically tells the link, because this is not a specific command for revolute or prismatic. Sigma tells the command whether it's a revolute or prismatic. So when it is 0, it's a revolute joint. Okay, and 1 is a prismatic joint. All right. So when we do a revolute joint, I can give it as 0. Sigma can be 0. When it's a prismatic, I can do this. If I don't mention this, by default, it will take it as a revolute joint. If sigma is not given, if sigma is not specified, the default is revolute. Okay. So it will just take it as a default revolute link if I don't specify this. Okay. So let me give you I'm going to give you an exercise sheet and this, and we will try to set this up. So let's say I have a simple 2 degree of freedom planar manipulator, right? So if I have a 2 degree of planar, L1, L2, this is revolute. Let's say, usually for a 2 degree of freedom revolute manipulator, you will have theta 2, this variable. All right, and this one will be A1, right? Whatever the length is, A2. Now, obviously, we need to give it some values, so I'm just going to give this as 1. Let's give this as 1.5. Okay, this is 0, 0, 0, 0. We did this in class. Let's try to set this manipulator up and see how we can work with this. Okay, and then you'll see how to graphically analyze everything. All right, so let's go here. I'm just going to start a new script. Actually, let me demonstrate the command first and then we'll start a script. Okay. So let's say that I want to define a link. So I'm going to call it L1. Okay. L1 is link. And make sure that L is a capital letter. Okay, this is case sensitive. L is a capital letter. So if you write it with a small L, it's not going to work. Now when we give sigma 0, 1, when sigma is 0, it will take theta as a variable. When you give it as 1, it will take d as a variable, okay, because those are variable parameters. Okay, so let's say I want to set up a link, which is a revolute link. So I'll say theta, I don't care about theta because it's revolute, 0, okay. Let's say theta d is 0, a is 1, alpha is 0. And this is a revolute link, so I'll give one more 0. Okay, this is defining a revolute link. So as soon as you click this, it will tell you this is a standard revolute link right here. You'll see this is a standard revolute link. Theta is q. Why does it say theta equal to q? It's a variable, right? Theta equal to q because it's a variable. D is 0. Your link length is 1. Twist alpha is 0 and offset is 0. So you can actually give a link offset. So let's say that the link always does not start from 0, it starts from something. So if I want to give an offset, you can also add an offset parameter here, but we don't really use it, so I'm not going to recommend that at this point. But these two are optional. As I mentioned, sigma by default will take it as 0, but if you want to give a prismatic link, then you have to give it as 1. So let's try a prismatic joint here. So what I'm going to do is, I'm going to say L2 is equal to, let's give theta as pi by 2. Okay, theta is pi by 2. 0. So whenever you write a DH table and you come up with 90 degrees, negative 90 degrees, please don't use, it has to be in radians, okay? You don't give that in degrees, make sure it's in radians. This is D, which is 1, right? I'm sorry, the sigma value is 1 because now we are trying to do a prismatic link, and here you have a standard prismatic link, theta in radians. Now you'll see that D is cube because D is variable. This is constant, constant, and offset is 0. Okay. So now we can combine these to construct a manipulator. But let's try to set up this manipulator first, and then we'll go to another one. Okay. So let's start a script. Click on a script here.
Professor, again, what's the purpose of offset?
Offset is, for example, you have theta is measured with respect to this line, right? Which is an extension. So theta 2 will be measured like this. Okay. So let's say that theta 2, what you do is you always have a default value of 30 degrees, let's say fixed. And then from there you are measuring. So you want to give it an initial offset. So any angle, so if you tell me theta 2 will be equal to theta 2 plus 30. This is your offset. Okay. For example, we did a question last time where you had a prismatic joint. So in the case of a prismatic joint, let's say that you have a joint like this. Okay, this is D2. All right. So you want to include this length also. So D2 will be equal to D2 plus 1 because this is an offset. Okay. When D2 is 0, it will still be 1 unit. Okay. So this changes up and down. But if you want to give an offset, you can give it as 1. So the least it can go is not 0. The least it can go is 1. Okay. So when this slides completely down like this, it is at 1. Or you can move this up to whatever length you want. Okay. So it will be 1 plus this x, whatever it is. Okay, so let's try to create a new script for a 2 degree of freedom manipulator. We'll change that to a 3 degree slowly, and then we'll go to a prismatic one. All right. So let's say, let me go here. All right. So we'll always start with clear all, close all, CLC. That will clear the memory. All right. Now, first thing is L1, link 1 will be equal to link, right? So we're going to use theta D. Theta we don't care about, so 0, 0, theta D. A, in this case, A1 is 1. So what I'm going to do is, I'll set up the link lengths first here. I'll say, I'm going to say like this, link length, A1 is 1 unit, and A2, let's say, is 1.5. Okay, so I can directly change it there. So this will be A1 and alpha. Alpha is 0, sigma is 1, okay, and then we'll close this. Okay. Let's see, let me save this. I'm going to just save this as planar. And let's see what we get here when we go here. So you have set up the link. This is a standard link. Now let's go back and add the second link here, L2. Exactly the same, only thing is the link length will change. I'm sorry, offset should be 0 because, I'm sorry, sigma should be 0 because it's a revolute joint. Okay? This is, I'm just going to say, So once we do that, let's see if it runs properly. Yeah. Let me dock this. So okay, let me keep it. Okay. So once you have done this, now what we can do is we can set up a manipulator structure based on link 1 and link 2. So the way you do that is we use a command which is called serial link. So we'll do is you'll give a robot name R will be equal to serial link. Within parameters you'll say L1, L2, the links that you want to combine to make a manipulator. Okay? So this will, serial link will make a serial manipulator. This will construct a serial manipulator based on the links that you specify. So this will construct a serial manipulator. Okay. This will construct a serial manipulator based on the links that we specify within the parentheses. So let's say is equal to, so in this case serial link L1, L2. All right. Now, let's run this. Once you do this, serial link L1, L2, and let's run this. Once you run this, you will see that you have a DH table here. Unfortunately, because of the large font, let me try to reduce this a little bit so we can bring this in context. Okay, so there you see a complete DH table here, right? Like we do in class. Only thing, the order is different. It's not A alpha D theta. Thetas are variable. D is 0. A are the link lengths. Alpha is 0. Offset is 0. Okay. You don't see sigma. The reason it's not showing sigma is because here you can know from here that it's a RR manipulator and it says RR here. Okay. On the top it will mention that both the joints are revolute. Okay. So now, what we want to do is, I'm going to show you one command to look at the manipulator. Now, this does not mean anything unless you see the manipulator in practice, right? So, whenever you want to plot a manipulator, you can plot it using the plot command. So, what we have to do is, we have to use the plot command, which is plot. So, if I want to plot it like this, plot, I'll say robot, which is the name of the robot manipulator, comma, the joint angles. Okay, so in this case we have two joints, so we should give two joint angles. Okay, this will be joint angles. Okay, so if I want to plot this, in my case, what I'll say is, I'll start with this. I'll say plot, comma. I have two angles, so I'll say pi by 4. Let's say I say pi by 4 and pi by 4, for example, to start with, right? Both of them are in degree, both of them are revolute joints, so I have to give angles. If it was a prismatic joint, I could give it a definite link length, which is a value. So here you'll see a manipulator, right? Once you plot that, you'll see a manipulator here, like this. And you can see the axis of the end effector. You'll see the 3 axes. Okay, these are the 2 joints. Now, this is okay, but if you want to actually run this, and if you want to do, in practice what happens is every manipulator comes with a teach pendant, so you can move the joints independently. So what we'll try to do is we'll try to emulate that in a program. Let's comment this, and I'll say, I'm just going to comment that line, and I'm going to say robot dot teach. So this will give me a teach pendant. Okay, it will give me a teach pendant, so I can teach this manipulator. Did I run this? No graphical robot of this name is found. All right, let's do this then. Okay, there is a overload of two functions. Give me 1 second.
Which one I have to download?
Yep. I know, but if you normally if you keep that, it will plot in the same window, and then it will work. I know that, but if you want to, give me 1 second. Let me check this. This will work because it has a window there at the back, but I'm just not trying to use the same window. Give me 1 second. All right, let's continue with this. Okay. So now here, let me get rid of this. Okay, so here what you can do is, you can set the value of Q1, Q2 using this sliding bar here. So if I want to set this as 0, like this, we can go, you can move the angles and you can see, and it will tell you at the same time what is the position of the end effector and roll pitch and yaw. RPY are the roll pitch and yaw angles here. Okay, this is your X, Y and Z positions. So what is the position of the end effector? You can get it from there. For example, if I set all of them as 0, let me go and I can double click here and give this as 0. We'll set this also as 0. So now you'll see that the total link length, which is 1 plus 1.5 along the X direction, you'll have this here, right? So you can check the position and you can verify the position of the end effector like this.
Excuse me, can you please show us one more time how to see this figure with the drawing?
Here. Okay.
Okay, thanks.
Okay, so now what you can do is let's go back. Let's add if I want to add a third link, if I want to make this a 3 degree of freedom manipulator, I can just go here, link. I'll add a third link here. So once I do that, if I add a third link there and I construct a manipulator, now you'll have a 3 degrees of freedom.
Professor, what about the black line?
Which black line? That is, okay, this is basically, if you look here, because the origin here goes from -5 to 5. This is at a 0 level. This is just a shadow of that, a projection of that to the ground, okay? So because it's exactly centered at 0, 0, you can change that by changing where you want to position the manipulator, okay? So let me explain, let's take a situation where you have a manipulator like this, right? And you have like this. If you want to plot two of them at the same time. So I'm just going to comment this part. Here, what we'll do is we want to use P2. Or you can actually, you know what, let's just do it here, where we can actually see this on comment. So if I run this now, even though the third link is there, I'm not making it a part of the manipulator because it's not given here within the serial link as L3. So let me look at the top view. Okay, so when you look from here, if I give this as 45 and this as -4, actually if I have the same link lengths it will work perfectly, but this will be a little off. Okay, so that is 45 and 45. Let me move this a little bit. So you can reach this point like this, in this angle, and you can also go above. So if I make this as -45, -45, or let's rotate this like this, and then we can bring this back. So what I'm trying to show you here is, obviously we'll do inverse kinematics. You'll have two solutions like this, the elbow up one from the top and from the elbow bottom like this. This is the elbow down configuration, the elbow up configuration for the same point in space. Okay, so I'm going to close this. Let's go to doing a different manipulator which has a prismatic link because it has a different set of problems. When you do a prismatic link, it has some different qualifications. So let's take an example. All right, let's take the case of a cylindrical manipulator. That's not your worksheet example. It is, so I have to find a different one. Okay, never mind, let me do that regardless.
We always use the revolute joints, like the movement is like that. How we gonna do this?
What do you mean like this or how? What do you mean?
Like the revolute joints,
Uh-huh.
we always the angles always of this side. We're
Yeah.
gonna move it like this side.
Why not?
Now when this is the joint. If you think like this
Uh-huh.
joint, we always think about it like how we gonna do this.
We did those, when we discussed the spherical manipulator like this, right?
Yes. You know what I mean.
Yeah. So you, that is how you set up an alpha value. This is Z naught. This is Z1, so you'll have a link first.
We need to
Right?
define the alpha.
Exactly.
Okay.
Okay, now, so let's take this example. It is a part of your question anyways. Let me just help you out regardless. Or let me do this. Okay, let's do this one. So we have a manipulator that has a prismatic joint. Let's look at the prismatic joint. So I have A, alpha, B, B. Okay, so here 0. I'm sorry. A is 0, 0, 0. That is actually, there is no D, so it's going to be problematic. These two will actually intersect. Okay, that's fine. We'll give it a D value later on to distinguish that. Okay, so A is that. Alpha minus 90 plus 90, 0. Okay. D, I'm just going to give it as 1. 1 is too high, let's give this as 0.5. D2, let's give this as 0.5. And this is D3, is obviously a variable. This is theta 1 is variable, theta 2 is variable, and theta 3 is 0. Okay, so we want, this is A. RRT manipulator. Let's try and set up the manipulator for this. Let's try to write the DH table, and I'll show you what happens when you do a DH table for this, especially when it comes to the last link. Okay, the first two are easy, let's do that.